Okay, in this video, we're going to look at controlling a three-phase induction motor using the Arduino Nano. Now the Nano is going to control the speed of the motor using a 0 to 20 milliamp current loop, and this is the circuitry here. So the Nano will output a pulse width modulation signal into the circuitry to create a 0 to 20 milliamp current loop. So 0% PWM signal will be zero current, which will be stop on the motor, and 100% PWM would be 20 milliamps in a current loop, which would be maximum speed on the motor. Now I've put an LED in my current loop so we could actually monitor the current through the brightness of the LED. And I got it mapped to the keyboard. So if I give it some PWM signal, you can see the current increasing on the LED, and that's 20 milliamps, so that would be maximum speed. And I could take the speed down by decreasing the current down to 0. So I have total control of my keyboard of the speed of the motor from 0 to 20 milliamps. Now to control the direction of the motor, either clockwise or counterclockwise or forward and reverse, I have an optocoupler feeding the digital input of the variable frequency drive. And so I can control the direction of the motor by sending a signal into the variable frequency drive. So if I send a clockwise signal, you see the left LED comes on. So that would be a clockwise or forward speed on the motor. Now if I type counterclockwise and send that into the motor, you can see now it's reverse direction. Now it's counterclockwise or reverse. Now to stop, if I send a stop signal, both LEDs will go off, so it'll indicate a stop. So there's two ways to stop the motor, either by the digital input or by sending a 0 milliamp current loop signal into the variable frequency drive.
Okay, here's a schematic diagram of the variable frequency drive that I use in my project. And if you look at the very left hand side, you can see the AC power input. So this is your single phase input into terminals L1 and L3. And if you look at the right hand side, you can see the three-phase power output on terminals T1, T2, and T3 that's feeding the three-phase motor. Now if you look at the very left hand side, you can see 5 push button switches labeled S1 to S5, and then there's a common terminal. So that's your multifunction input. So you could program those switches to do anything you want. So I program switch S1 and S2 to be my direction control for clockwise and counterclockwise direction of the motor. So if I connect terminals S1 to common, my motor will spin clockwise, and if I connect my terminals S2 to common, my motor will spin counterclockwise. And if both are open circuit, then the motor will stop. And that will be an inverter stop. That would be a power stop. It's stopped by killing the power from the inverters to the motor. Now instead of using push button switches, I use 2 optocouplers that have been driven by the Nano's GPIO to control my clockwise and counterclockwise control. Now if you look further down on the left hand side, you can see the ACI input. That's analog current input. That's your 0 to 20 milliamp loop. And that's used to control the speed of the motor. So my Nano can control a 0 to 20 milliamp current loop, and that's fed into the ACI input. So I control the speed using my 0 to 20 milliamp current loop, and I use my multifunction input S1 and S2 to control my direction control. So with these inputs and my Nano, I have total control over my three-phase motor.
Okay, my variable frequency drive is powered up, and you can see the forward LED is blinking, so it's in the forward mode. And the front pot is disabled. It's not controlling the speed. So the Arduino Nano is controlling the speed of the variable frequency drive through the 20 milliamp current loop interface, which you can see on the strip here. It's labeled ACI for analog current input, and you can see the 2 wires there feeding the analog current input. And if you look at the very left, you can see switch 1 and switch 2. That's my forward and reverse control that's hooked up to the Nano. So if I give some current into the 20 milliamp current loop into the motor, you can see it being activated. So now the motor is starting to spin. So I got the motor running. I can take it up and I can take it down. So I'm controlling it through the Nano, controlled by my keyboard, all the way back down to stop. Okay, this is my three-phase motor, and I have it coupled up to a gear drive. This is the gear drive here, and you can get it in different gear ratios. And this is the output of the drive. So you put in some keyed round stock into here, and that'll drive your project. So if I give some current into my current loop through my keyboard, I can start up the motor. And if you look at my breadboard, you can see my my clockwise LED is on, my direction LED, so it's going to run clockwise. So I'll give it some current. I can slowly bring it up. It's running clockwise. I can bring it up to speed, or I can bring it back down just by changing the current in the current loop. I'll bring it all the way back down to stop. So in my code, the way I would control the speed of the motor, I would give it a percentage value. So if we look at the breadboard, you can see my clockwise LED is on. So I'll give it 50%. I'll type that onto my keyboard. 50%. So that would be half my speed. So she goes up to half speed. I can go 20%. That'd be 20% drive. And you can see it's running clockwise, and I could actually change it to counterclockwise from the keyboard. So she changes direction, and it'll go to the same speed as if it was in clockwise, so the speed doesn't change. So I could alternate between clockwise and counterclockwise, and it'll run at the same speed. So I'll take it up to 100%. So it's maximum speed, and I'll take it down to 0%. That takes it back down to stop.
Okay, here's the code running on my Nano to control my three-phase motor. Now this code is written in Forth, so I could execute the code from the keyboard for troubleshooting. Now I'm using timer counter number 1 on the Nano, and I'm configuring that as mode 14, so that's fast PWM. And I'm using a prescale of divide by 1, so I'm using the full 16 megahertz clock to drive the PWM circuitry. Now the output of the PWM will be out of pin 9, so I've set pin 9 as an output in the GPIO. And I've entered a value of 2015 into my input capture register. That sets my TOP, that sets my top value, so the counter will count from 0 to 2015 and then back down to 0 again, and I'll continue on over and over again. And that'll give me my pulse width modulation period. So all I have to do is enter a value into the output compare register to give me my pulse width. So I enter a value from 0 to 2015, and that'll give me my pulse width. So the next word is init opto, and that sets up my opto isolators, and they're on pin 7 and pin 8. So I'm setting them as outputs, and I'm driving them low. And that'll control my direction, my clockwise and my counterclockwise direction on my opto isolators. So the next 4 words are the heart of the commands. The first word is percent. So if I type 0%, I'll get a stop speed. If I type 100%, I'll get maximum speed. So if I type 50%, it'll take 50, multiply it by 2015, and divide by 100. And that value will be put into the output compare register, which will give me a pulse width to drive my motor at 50% speed. So next is stop, and that will set my opto isolators for a stop configuration. And clockwise will set my opto isolators for clockwise, also for counterclockwise. Now this next word, demo, is going to use these commands in a sequence, and it will run this sequence, and it will control this motor in each step here, as we can see each command. So what I'll do, I'll actually run this program on my motor, and we can actually see it respond to the demo program. It's just a little silly program, but it just will give you an idea how to send sequence commands to the motor. Now on the very bottom we see 0%, and that's a 0% stop. So that actually will stop the motor by sending the frequency to 0 hertz. Now the next stop is the stop by the opto isolators, and that will kill the inverter power to the motor to stop it. But the speed information is intact, so as soon as you go to a direction, like clockwise, it'll resume the last speed that it saw. But if you stop the motor with a 0%, then you got to ramp up the speed to whatever desired speed that you want. So next we'll actually run this demo program and see how the motor responds.
Okay, I'm going to run my little demo program. So it's my little silly program. It really doesn't do anything. It's just a demo on some sequence programming. So watch the direction and speed of the motor, and watch the 2 direction LEDs, and we'll go through our sequence code. So I'll start that now. So first of all, it's going to go into stop mode for 2 seconds. Then watch the clockwise LED come on for 3 seconds. Then it's going to go to 50% speed for 5 seconds. And then 20% speed for 5 seconds. That's clockwise. Now it changes to counterclockwise for 5 seconds. Then it's going to go 100% for 5 seconds. That's a 0%, that's a frequency stop for 5 seconds. Then the LED will change to clockwise, and it'll hold there for 5 seconds. Then go up to 75% speed clockwise for 8 seconds. It'll do a 0% stop, and then it'll go to a digital stop. You'll see the LED go out.
Okay, if you want to control your own three-phase motor, but you don't want to build the circuitry involved, you could get the off-the-shelf PWM to current or voltage signal converter like this one here, made by Axiomatic. So you could get a PWM to 0 to 20 milliamps or a PWM from 0 to 10 volts. And you could use either one of these to feed the variable frequency drive like the one I was using to control your own three-phase motor. This way you could use any microcontroller or your favorite single board computer to control the three-phase motor. So I hope this video gave you some ideas how to control your own three-phase motor with your favorite microcontroller.